Good morning again. This is we're gonna actually work on lecture 4 today. Last time when we did the lecture, I tried to share my screen to show you a little bit some of the features of MATLAB. For some reason, it did not record what I was doing. So what I'm gonna do today, there was a problem, example problem from last presentation slide that I did actually, but you did not get a chance to see the screen. I'm gonna redo it. It's just simple problem, plotting problem. And I want to talk a little bit also back about MATLAB features and all this menu. So let me share the screen today. Hopefully things today will work better. So let's do that. So we go to, let me go to first to MATLAB. So this is my, this is my screen here. So just make sure here, this one is. Okay. Okay. So going back to the screen here. All right. So this is when you open MATLAB. This is what you're gonna get. I talked about it last time, but I don't think you guys get my screen capture. So you'll see that this is home, and all you see this is the menu. This space here in the middle, the command window right there, is this is where you can actually execute your program or your function. You can definitely work on this and you can get your result. You can write your code or your program, whatever you choose to do, and then you can execute it. You can actually call a function and execute it. And again, every time you hit enter, you execute the command. If you enter the equation, you will execute it, and the result will come up. And this is something you've already seen. Again, for those of you, most of you took Comp 1. So you should be able to, again, in that command window, to write your program to execute if you want. But we are not going to use this except for to execute our script file or program that we, or a function that we already saved. So on the left-hand side, this box here on the left, this is where your current folder is. This is where you are going to, this is where you're gonna save your folder or your script file. Make sure here you change your directory to your Z drive, because if you change it to your Z drive, you can always access it from anywhere else. And I believe you have more memory in your Z drive than any other drive, so you can change that directory. In here on the left-hand side in the bottom, you see this is the workspace. This is where you save all your variables. So you can define A, you can define X, you define Y, whatever. It will save it, and you can actually you can, if you really want to change what is saved, you can just rewrite or redefine X or redefine Y, for example, and you get different value. So you can see that this is like a memory for all the variables. Again, with CLC, you can clear all the screen. Clear, it clears all clear command will clear all the command window plus the workspace. So in here, you will see here you have a new script, and this is what I need you guys to work and focus, because what we are going to do, we're gonna start writing scripts, which is a program, and this program we're gonna save it, and once we want to execute it, we just have to run in time you run it, or you just call that script file from the command window, and then it will be executed. So this is the new script, and when you save it, it's saved as .m, which is a MATLAB file, and you can call it anytime and then execute it anytime. There's tons of features. You can. I don't have to explain all of them because we'll cover them as we go right now. But this is the layout. If you don't like the way your screen has been divided, you can change that layout. Simulink will we'll cover that later on, later in the semester, and definitely can add ons to this system if you want to add more simulations. The most important thing again is how to save the script and how to name it. We talked about it last time. If you need help, you'll see here that search documentation. This is what I use. I don't call it from the command window. I just hit, for example, sign, and then it gives me how you're supposed to execute a command sign or cosine or tangent or whatever function you want, exponential. So any information that you need that you forget, or you can always hit the search documentation and it takes you there. And like I mentioned before, as we are going to be writing code program, you will see that MATLAB, it is self-debugging software, so it will actually automatically highlight things in red for us that, oh, okay, well, you're doing something not good. You need to stop and correct your mistakes. So this is what I actually was trying to show you last time. I did not do. And another thing I wanted, I'm gonna jump into this, and that tells you, again, this is the, this is the, whatever you just saw in here. Again, this is the command window. This is where the directory you're gonna have, and it lists all the files that you need. And here, the workspace, I mean, this is different layout because this one was just under this. So you can actually change the layout any way you want. This is where you hit. All right, and that's what I'm talking about, the search documentation, where if you need help for that. And this is Simulink. We'll cover that later on as well. So this is pretty much what I wanted to cover last time. Now today, I'm going to start. So let me exit from this one, and I'm going to go to Canvas, and you guys at the same time you can access your Canvas, and I have already uploaded all the in-class problems that we are going to work on all semester long. So we're going to do it chapter 1, chapter 2, chapter 3 as we go, and this is you guys can start working on this on your own if you want. And this is exactly what I talked last time. While you're watching this lecture, open your MATLAB and try to do the work yourself. It's really important to do it yourself, not just to see how I'm doing it, right? I need you to practice. So please open your MATLAB. You can pause the video, the lecture video, and until you open your MATLAB and you start working. So let's read the first problem here. So this is, I'm going to read the problem, then I'm going to split the screen so you can see both screen, but this is, let me just move this one to the back. So let's see here. Yeah, so this is the command line space a parentheses a comma b comma n generates a row vector of n equally spaced points between a and b. So use the column notation to write an alternative one-line command to generate the same vector. Test your formulation from a equal -3, b equal 5, and n equal 6. Remember, we talked about how we create an array. We use the semicolon or the column to do column notation to do this. Again, you put initial value, increment value, column increment value, and then column final value. That's the easy way of doing it. Now, another command MATLAB can use is the line space. So what we want to do, we want to use both, and we want to see if really they agree with the both results. So you're going to have the same result. So what I'm going to do, first I'm going to do this one here, and I'm going to take it to the left. All right. I don't know if I can. All right. And where's MATLAB? Right there. I'm just going to take this one to the right. So this is, I'm going to enlarge this one here. So we know exactly what we want. So I'm going to do this in the command window for now. Next time we'll start working in a script file is better, so we can save it, and then always we can edit it if we want to. So I want to use the line space command first. So we're going to say, so I want to actually do two things. I wanted to do the, let's do the column command first. So we have a is equal -3. So let's do x, let's choose this a column, and I'm gonna do, yeah, let's just do that, and then well, yeah, let's do the line space, then we do the other one. So a is defined as -3, right? So that's, I'm going to use the semicolon to suppress, because I don't want MATLAB to show me again what is that value, and then b equal to 5, and also semicolon, and n equal 6, and also semicolon. So if you really hit this, you're not gonna see anything, because it's not gonna redefine those a, b, and n for you, because you suppress those. And then you're gonna say line space, and remember you're gonna open a parenthesis. And if you notice, MATLAB already give us a hint here how you are supposed to execute this command. So we're gonna put x1, which is in this case a, right, and b, and also n in this case, and we're gonna close the parentheses. So again, in this case, n will be the in this case a will be -3. So what we're doing, we're gonna get an array. We're gonna start with -3, right, and then we're gonna go -1.4, 0.2, with n numbers, which is total of 6 numbers. And but we have b is we define b at, let me just enlarge this one here. Okay, so we have 1, 2, 3, 4, 5, 6 indices in one array, and that's what n is. N is going to give you the number or the size of this vector or this array, right? And again, a is going to give you the initial value, B will be the final value, and N is the number of array. Now, how can we form very similar array using the column feature? So in this case, you just do A. Remember A, if you notice in here, if you look at this workspace, you will see that A is already been defined for us, B is already defined, and N is already defined. So these, whatever we saved, whatever we define, it is saved in the workspace. Unless you redefine A with another number, it will change it for us. So we don't have to redo this first row that we did here. We don't have really to do that. It is already done. So we're going to start with A as initial value. We have to do the column, and then we do, in this case, the increment, which is B minus A. And how we're going to define the increment is B minus A. So the initial, so the final minus the initial divided by N minus 1. The size of the array divided by minus 1, that will give you the increment. So what the difference between the initial and the final number, and then you just divide it by the size of the array minus 1. So that will be your increment, and then you do the column, and then from there you put the final value, which is, what is the final value, which is B. And if you just want to see if what you did is right, you hit enter, and it will give you, if you notice, it will give you the same value, right? Okay, so -3 to 5, and you see that it is the same. So two features, you can use the line space, or you can use the column column features to do the arrays, or to form array or vector. Okay, so that's probably something that, or definitely you've seen before. Just this is a small review, because we are going to definitely work with array as well. So I did enlarge the font in this. I don't know if this is too big or something. We'll see. Probably will decrease the size as we go. But let's move to the second problem. And like I said, whatever I did, I really like you to do the same thing. So let me enlarge this, and let's read this problem first. And maybe it would be better to, let me just download it, so I increase the font a little bit. It would be better also for you to do the same thing, split the screen when you're working. So that will be the, all right, so let's read this one. Again, here I'm missing problem here. So problem 2, what do we have here? The following equation can be used to compute values of y as a function of x. Now A and B are parameters of this equation. Write the equation for implementation with MATLAB for A equal to, B equal to, and x is a vector holding values from 0 to pi over 2 in an increment of delta x of pi over 40. So it's going to give us the increment. Employ the minimum number of periods, i.e. dot notation, so that your formulation yields a vector for y. In addition, compute the vector z equal y squared, where each element holds the square of each element of y. Combine x, y, and z into a matrix W, where each column holds one of the variables. Display W using the short G format. In addition, generate a label a labeled plot of y and z versus x. Include a legend on the plot. Again, use help to understand how to do this if you need. Now, for y, use a 1.5 point dash dotted red line with 14 point red edged white face pentagram shape markers. Now, for z, use a standard size, i.e. default solid blue line with a standard size blue edge green face square markers. So this to distinguish the difference between the two plots. So this is something that again, something you've already been exposed to in Comp 1, where you write an equation for an array, and you just want to make sure that you have the dot in there, because when you're dealing with array, when you do the division or product or whatever, you gotta make sure that you have the dot in there. And plus, the second part is the plotting part, where we're gonna plot two different curves in one figure. Right. So we will start first. This time I am going to try to write a script for this. So this way we can save it. And just by saving it, will be easier for us to do that, because if you ever make mistake, you don't have to use the up and down arrow to do this. You will be able to just go back to the script and edit it, and try to rerun it. If you have a mistake, it will tell you what line, like you're gonna see that you have an error, and then you have to fix it. All right, so again, let's split the screen again. And I'm gonna go back to MATLAB. And so what I wanna do, just this one here. All right, so let me start by writing a script. And so what I want to do, I want to start by new script here. And when you hit on new script on the left, it's going to say here, it's going to open a file, a script file that's untitled. You can always save it later on. It doesn't matter if you want. And you can write your program in this and save it. And then when you're ready to execute it, you just hit run right there, that button there. Or you can just call it from the command window. So we're not gonna work on the command window now. For now, we wanna just work on our script. So I'll start by making sure that I fix the, it says here that it says to format G format, so which means short G format, which gonna give you up to 4 significant digits for that. So so let's start with this. Let's start with format. So let's write format. Let's go back to the script file and write format here. And we're gonna do short and G. All right, so that's what they want. And as you can see, it will highlight this purple. It tells us that this is the right command. And then A, in this case, is giving us A to be equal, just this one here, A equal 2, B equal 5. So A equal 2. And always I'm going to use A equal 2, right? And my column B equal 5 and also semicolon. Okay, all right, I'm going slow for the first couple of problems, just to get you guys moving, get the right way, and get you going. So let's see X. Let's do now the array and the vector X. So X equal, we have, we're going to start with 0, and then we're going to do the column, and it says pi over 40. That's delta X. Just that it tells us that this is, if you look in here, that is, if you look at that, this is delta X right there, right? And it is from 0 to pi over 2, right? 0 to pi over 2. And delta X is pi over 40. So the increment will be equal to 40. Keep switching here. So 40 divided, sorry, pi divided by 40. So pi divided by 40. Okay, so that is the increment. And then we'll do the column, and the final will be pi over 2. Right? So from 0 to 90 degrees with a 40 increments, or 41 increments. So, all right, so that's X. Do I want to see X? Because if I hit, if I don't suppress it with the semicolon, when I execute my command, it's going to give me the value of X. And I'm not ready to do that, so I'm just going to do the semicolon. I want to suppress it. And then I'm going to now write Y. So Y, in this case, we're going to write this equation. So Y, let's just do Y here. So Y is equal E, right, times, right, and exponential, we use EXP, and you open a bracket, which is minus A, and times X, times X. And then you're going to close the parentheses. And remember, because you're multiplying sine B of X of another also variables, you need here to use the so e to the power minus x, ax times sine of bx. So in this case, you're going to use the dot. So it is, in this case, dot star, and that will give you, it tells you, you're telling MATLAB it's an array that you're working with. So for every value of x, you are getting a value of y, and we want to make sure you use the dot in the right order. So times sine, and then you sine, and you open b, it's b of x, so b, and b times x. Now you might tell me, why didn't I put b dot star x? You can, but it doesn't really make any difference because b is a constant anyways. It's not, you're not multiplying a variable with another same variable. So you can do that, but it doesn't matter. It's not going to make any difference. So when you have a variable, a constant times a variable, you don't really have to do the dot. All right, so dot again times, you have the star, or the product, and then you have, you're going to open the parentheses, and you have 0.012 times times x, but what we want to do here, it is x and to the power 4, so I'm going to just do dot to the power 4, right? And minus 0.15 times x, also dot to the power 3 plus 0.075. Yeah, let me enlarge this one here. Right, so 0.075 times and x, also dot square, use the caret for the exponential, and plus 2.5 dot 2.5 dot x. And I guess that's it. You're just going to close the parentheses. Okay. So this is the equation of y. What I'm going to do, I'm going to also suppress that for now. Now, I'm not going to worry if I made a mistake or not. For now, I'll do that when I run my program. It doesn't look like I made any mistake yet, but if I do, when I execute my program, definitely MATLAB will tell me, okay, well, you made a mistake at this, at this line, and then you can also go back and fix it or edit it. So what I'm going to do here, so this is the y, but he wants z to be equal y squared. So z, let's start a new line. Z is equal to y, and don't forget, z is also a vector or an array. So you're going to do dot, and then this is to the power, and then also I'm going to suppress my result. So we have y, x is the original array. Now y, we have another array, and z is the square of y. So the output, we want to have the output, which is with the table. Before we plot, we just have to do the table in here. So let's do the table as a vector. So w is equal to x. And let me open a bracket. I'm going to do x, and again, it is the transpose. So transpose, you put an apostrophe, and then y, also apostrophe, and the. So what we're doing, whatever array we got, we want it to be transposed. So when we display it, let me close this. When we display it as we display it as a table if you want. Okay. So, and let me see. Let's just do okay here. Did I do something wrong? All right. You don't have to suppress this because the reason why, because you really want to show this. So let's move to plot now, because we want to also plot this one here. So we want to plot xy, and we want to plot what else? And we want to plot also xz. And but he's telling us how to color this, what type of color, and what type of size, and the line width. Is giving us all this. So let's start with xy. So let's just reread this one here before we come back. So let's reread it because we want to be very sure what we're doing is right. First of all, when we plot, so we're going to display W using the short G format. And also, we want to plot X, Y. So include the legend. So for Y, use a 1.5 point. So we're going to do the line width to be 1.5. Dash dotted. So we're going to use that as well. And the red line with 14 point and red edge with phased pentagram shaped markers. Now, do I expect you to learn how to do all of this? Because you have to remember that? No. You can always, if you don't know or you don't remember the command for these, you can just go to plots and all the features of plottings and all the options that you have for dash dotted or for fonts and for line size, you can get all of this from, and all the shape markers, you can get them from help. You just have to make sure that you execute the right command in the right format. Okay, so, and for Z, we're going to use standard size, solid blue line with standard size blue edge, green face, square markers. Okay, and we actually, what we want to do, we want to plot this in one figure. So we're going to use the hold command to do that. All right, so let's plot X and Y first. So let's just do this one here. Let's go back in here. All right, maybe I'll enlarge it a little bit. Okay. So we are here at the now plot. Let's see here, plot X, always X in the X-axis and then Y. So we are plotting X versus Y. And yeah, let's see what we want to do. There's the red line and the, so we have, yeah, that's comma. And we're gonna do up in the apostrophe minus dot R. Also close the apostrophe. All right. So when it is changed that color, that means you're doing it the right way. And then let's define the line width. So also line width, and we want to define that one as well to be 1.5. So comma 1.5, and again comma line width. All right, very good. So, and then we want to do the marker size. So we open also a apostrophe, then we do marker size. So let's do this one here in capital. And then we make sure to close that. And that is, we want it to be also 14, so comma 14. And I want to do something here. Let's do also a comma, and then I'm going to use the 3 dots because I want to continue on the next line. So, and then just go down, and this, it's not interrupting my line coding. It's just I'm using more space by using 2 lines instead of 1. Still in the same code that we're doing, and then we're going to do the mark edge color. So marker, and then edge, marker edge color, because he wanted to be red. So I'll do this, and then comma R. Just to don't forget the apostrophe there. R. So now we have the line width. We have the dashed line. Line width. We have the marker size, and we have the marker edge color. And we want to see the face, the marker face color. You want it to be white. So I'm going to also do a comma, and then again open a apostrophe here, and we do the marker face color, and we'll close that, and comma, and I'm going to do this white, right? And just do this one like that, and that should do it. Okay. So, and as you notice, when you close the parentheses, it just will highlight the first parentheses that you open. So that is the first plot, which is x versus y. And we'll see if we made any mistake or not. So now what we want to do, the second plot. But before we do that, let's do another line. I'm gonna say hold on, and the reason why you want to do the hold on, because you do not want to have a separate plot for each. Same figure, 2 curves. So you do hold on, it stays in the same figure. And then we'll do the plot. Same thing now, but now we're going to do the x and z. So x, z, and again standard. So we're going to do comma, that's b. Hold on just a minute here. Sorry, minus b. All right. So now we want to do the marker face color. You want it to be green. So marker face color. Now, if you, yeah, the marker face color wants the green. It doesn't care about the marker size and all this. It cares just the marker face color. I mean, I can really copy it and put it and just change white from green from the previous if you want, but let's just do it, you know, step by step is better. So, and then you have W, want it to be white, and let's close the parentheses. So just make sure we have that. Standard size, blue edged, and green, right? Green marker freeze color. Okay. So, and let's X label and let's Y label. So X label, and this is X. Let's just do X. All right. And from my column, Y label. So X label, Y label. I mean, even if you don't do this, once you plot your figure, you can always edit your figure and X labeled and Y labeled any way you want. But you know, let's get used to do that. Is better. So for the Y label, remember we're plotting Y and Z, so we have to have 2 variables in there. So apostrophe, I have Y and Z, and this one here, and then we're going to close the parentheses. And let's do the legend. Legend. And because we have two plots, we're going to start with y. So y, and also z. Just make sure. You know, when you don't, you forget to put any features or any, like I just forget to put an apostrophe, it automatically tell me that, oh, you're doing something wrong. So you just have to fix it right there. So we have X label, Y label, we did the legend, and then now we just have to do hold off. Because remember, we hold on, and every time you hold on a curve, you want to do a hold off. Okay, so now I'm done with this, but I want to save that. So how do I save the script? So I'm going to just do here, save as. And I'm going to call this one, what is the number of this one here? 210. So I'm going to say that this is a problem. To lower here problem, and I'm going to use underscore to underscore 10. Okay. And where do I want to? You can choose where you want to. I'm going to actually choose on my PC because I want to go back to that. So I'm going to just do here under MATLAB, and I'm going to do save all my file in there. So this is a great thing because now we have, if you look on the left-hand side, you'll see that this script's been saved, right? So, and you really do not want to run it. If you try to run it before you save it, MATLAB is going to say, is going to ask you, save your work before you run your code. So that's exactly what we want to do. Now we save it, so we're ready to run it. So let's see. Let's hit run for now and see what we get. So let me enlarge this so you can see what we get in here. All right, so let's go down and see what we have. So if we look at, maybe if I can, all right, so you see that this is it. This is the array right there. And again, it tells you this is X and this is Y and this is Z. And it gives us this as a column. And now we want to see where the figure is that we did. So this is the figure right there. And something that we did, if you look at what we have in here, we have plotted Y and Z. If you look on the, let me see if I can work on this here. Okay, I guess. Well, you know, I can probably do something in here. No, I can't. So, so if you see that, that's exactly what we wanted. We plot Y and Z versus X, and you see that. Yeah. So if you notice, Y is the red dotted line, and you see there's a star in there, a red star, and the other one is a white square with a blue normal line. Okay, and then you have Y and Z versus X. and we wanted both of them to be plotted in the same figure. Now, like I said, you can always change whatever you want. You can title it. You can insert a title if you want. So you can do whatever you want. In this case, you can change the legend if you want. You can change the X label, the Y label, and you can do title, for example, and add to it whatever you want. And then save it, and you can export it as a JPG file or PDF file, whatever you like to do. Okay, so definitely what I need from you, I need you to definitely do whatever I did, rewrite the program yourself in MATLAB and try to use all these plots in there. So let me, every time I'm gonna write something, so again, figure will come up on the bottom here. So if you want to go back to the results, you can always, if I'm asking you to show me this in your homework or your exam, or you definitely what you want to do, you want to take a snip for this and you cut it, because I want to see that table, and then you paste it in your work document. And same is true when you're doing the plot. When you have the figure, you definitely also copy this and also insert it in your Word document, where you're going to save all the problems. If you have 5 or 6 problems for your homework, you save them, and then you save it as a PDF, and then you upload it on Canvas. Okay, so very important. I want to see those plots. I don't need to run all your programs to do that. I want to see your results. I will be running, like I said, your program randomly. There's 45, maybe more of you in class, and just imagine 6 to 7 programs and codes, a homework. That's hundreds and hundreds of codes over a maybe 10 or 12 homework assignments. So that's a lot of problems and programs to run and figure out your mistakes. So I want to make sure that you're doing the right thing. You write the right script, and you run your program. Program is working. Your results is just right under your script, so I can check them, right? And then all should be uploaded with the M file, which is this file here that we talked about. Let me enlarge this again, because this is what I am interested to see. You can always also take a snip for this, right? You'll just take a snip, and let me just do this snip is better. Where is that? Here we go. So we go back in there and new, and all I do is just take this one like that, and then open. You can open a window or a let's suppose a new new file, documents. So I'm just showing you how to do that for your homework. Definitely choose the 2 columns layout if you want. Again, 2 columns, right? And then paste that in there, right? And also what I want you to do, you go to the, remember what I did here for the command window. I'm gonna go back to this one here because I wanna also copy, snip, new on this, and then do this one right there. And where's my document? Right there. And I'm just gonna paste it right in there. And then also, I want to do the plot. So you go, where's that here? Yeah. And remember the figure, right? And you know, whatever you want, you can just do here. Let's just do copy here, or just do the snip if you don't want to do this. Just do the snip. And yeah, and just do this one here, and just copy it and paste it. Where's that word right there? And remember that will be pasted right there. Okay, so that is problem one. You can actually name this problem one or problem 1-2, whatever you want to as a title, and then you go. The next will be problem 2, problem 3, and then use the 2 column, so you don't have to have multiple pages for like 5 or 6 problems. Okay, so yeah, so pretty much that's what I need from you when you work your program. And then after you finish, you go and you save this, save as, and make sure. Let's suppose that I want to do it in documents, and what you want to do, you go choose PDF right there, PDF file, and then you save it, and then you upload it. Okay, so let's just exit from here. I'm not saving this, so this is pretty much it for this particular problem. This one here, no saving. Going back to MATLAB here. Right, and that here, if you look at this problem here, problem 2, then that is the M file that I needed to save as well, and also put all of these problems. For example, if you have 210, 212, 213, whatever set of problems you have, you save all of them, put them all in a zip, and call it homework 2, for example, or homework 1, and then upload that. So I'll be able to access that as well. Okay, so that's very important to know how to do. And again, if you miss anything, if I'm missing anything, please follow the step-by-step procedure that we talked about in the first lecture. All right, so let's do something a little bit different now. Let's do one more problem. So, all right, so we did plotting. Let's read what we have. Maybe we have some more. Again, I'm going to try to do as many problems as possible in class, but I do expect you guys to know how to do all of this more than, I mean, you guys took Comp 1, you should be able to do all these plotting features, equations, and all this stuff. Just, you know, consider it as a good review. This way, easier for you to remember everything that you learned. Now, some of you took it last year, some of you took it a couple of years ago, so that's why I'm doing this. All right, so let's read this before let's read this one here. So we have the standard normal probability density function is a bell-shaped curve that can be represented as f of z is 1 over square root of 2 pi e to the power minus z squared over 2. Use MATLAB to generate a plot of this function from z equal minus 5 to 5, label it or the ordinate as a frequency and the abscissa as z. Okay, it's given as the function. And it's telling us we wanted to plot between z minus 5 to 5, and we want to see what we get. Okay, so it's pretty much we just have to do the we just have to do an array. Now we can use the line space if you want. It did not really tell us how many. It never told us how many the size of an array, so we can do whatever you want. And the function is right there, so we can just do. Oh, so let's start. Since we did the line space, let's do the line space, or you can do whatever you please to do your array. Okay, you can do just the common method, or you can do the line space method. So let's go back to this one here. And what I want to do, I really want to start a new script. And I get used to start with a new script. Let me just get out from this here. Tell me I get out from there. Okay, I guess that's what happened. So, yeah. So let me resign there. When you're working with multiple screens, you tend to make mistakes and actually close your screen that you really do not want to close. So again, we're back into this, and I'm going to just go back to this one here. And remember, this is problem 210, so I'm going to open a new script right there, and it says untitled 2. I'll save it later on. So I'm going to start with z here is equal to line space, and I'm going to do it minus 5 to 5. Okay. And then what else? I just have to write the function here, so let's just suppress these. You can actually, if you want, you can define how many n. I believe the default increment for this will be 1. So you're going to get minus 5, minus 4, minus 4, unless you define the number that you want. If you want 20, the size of 20 increments, or more than that, the size of your array. So if you leave it, you don't put the n in there, that means you just going with the defaulted n value. All right, so that's because from minus 5 to 5 actually will be yeah, the 11 values. So let's put the function now f. Again, don't forget to suppress it, because otherwise it will give you the value of z, which is you really don't really need to see. So the function is equal 1 divided by square root of 2 times pi, right, times exponential of minus z, and don't forget the dot in here, because you're squaring this 2, and then you're going to do over 2. Okay, so z, and that's right there, exponential of, let me just look back to the equation just to make sure. So z squared over 2, so minus z squared over 2, 1 over square root 2 pi. And you know what? I'm gonna suppress that because I don't not want to visualize it or see it. And then just going to do plot Z F. And you want to X label, you can do that if you want. X label and Z label, Y label. So X label, you can do Z, and Z, and Y label. Yeah, you can just do Y label if you want. Frequency, maybe you want to do frequency, right? And then close it. So, and before I do this, you can save it. I mean, if you try to run it, it's going to tell you to save. So I'm just going to save it. So I'm going to just go to save as, and I'm going to save it in the same directory. And I'm just going to do problem 212. Okay. I'm just going to save that and hit run in there. So by just hitting run, you have a new figure, and that's what you have: frequency versus Z. I don't know why my screen is too. For some reason, my doesn't show all my screen in there. Let me just. Oh, here we go. All right. Yeah, much better. For some reason, that one was blocking my x-axis. All right, so that is the probability bell shape, if you remember. For those of you who took statistics, and you'll see that frequency versus Z. And again, you can change a lot of things if you want. With these tools that you have, you can insert, for example, you can use the tools. What else you can do here? There's tons of things that you can do and edit your plot to do this. I know the grid was there. Edit. Options. Tools. Or you can just hit, do the grid command in there. But I remember that there is an option where you can use the grid right there. Insert. Again, you can insert legend, you can title it, you can do whatever you like to do. Yeah, it's just a little bit odd that you don't see the grid in there. Maybe it's in there and I don't see it. Anyway, yeah, so we'll, I guess we'll stop here today. We're going to continue. We have more problems. So again, what you really want to do, and what I like you to do, is if you did not do whatever we did within the lecture video, I need you to do that on your own. Again, you can replay this lecture and then and do it. Again, you can always pause or change the speed to slow speed when you play it, and do that on your own. So next time we'll do this. This is very important. The Maclaurin series expansion, where we're going to draw this using this expansion, and draw it actually when we use the cosine function, and see if how close we are with this. So all right, so I guess we'll stop here. Next time we'll continue on this, and we'll do more problems as well. So let's stop sharing in here, and let's see here.